If you've ever looked into latch circuits, you have probably seen the classic design. One button to turn it on and another to reset it. But that setup isn't the smartest. What if you could control everything with just one button? Sounds cool, right? Now, what if we could take it even further? What if the circuit could react to motion instead? That is exactly what I built, a smart motion activated latch circuit with no ICs or microcontrollers. And once I saw it worked, I went ahead and built it on the PCB software. Let me show you how. To understand how this works, we need to talk about how transistors can latch. Normally, a p-channel MOSFET turns on when its gate is pulled low and turns off when the gate is at 5V. Right now, a pull-up resistor is keeping the gate at 5V, so the MOSFET is off. But in this circuit, how do we turn it on? Well, the NPN transistor connected to the MOSFET gate, when we press the switch, it temporarily lets current flow into the transistor base from our 5V, activating it. This pulls the gate to ground, switching the MOSFET on. And now, since the MOSFET is on, it keeps supplying voltage to the transistor. So even after you release the button, the circuit stays on. That's what we call a latch. Simple, right? Now, if this circuit is on, we should be able to turn it off by pressing the button again, right? But it doesn't work. Even if we press the button again, the circuit stays on, except I have to keep taking out the transistor and replacing it back. Why? The reason is simple. The transistor is still getting 5V at its base from the MOSFET output. Even if we try to break the circuit with the button, the transistor stays on, keeping the MOSFET on forever. You see, it is a loop. So how do we fix this? You see, if we add a second switch that will pull the base of the transistor low whenever it's pressed, then this will reset the entire circuit. But doing this isn't the best way, because now we have two switches which controls a single circuit. We don't want that. We need a way to pull the base of the transistor to ground when we press the button again. That's where the second transistor and RC network come in. This transistor's job is simple. Pull the base of the first transistor to ground when the button is pressed again. This happens because the output of the transistor at the collector becomes 0V, where the switch is held to, whenever this transistor is on. But when it is in off state, the output stays at 5V, which is our VCC, that is being pulled up by our resistor. How does it know when to reset? That's where the RC network, resistor, and capacitor comes in. If we just used a resistor, the circuit could react too quickly and we might get false triggers, as you can see how the circuits behave. The capacitor is used to slow its switching time down, ensuring that when the button is pressed the second time, the second transistor stays on, just long enough to pull the base of the first transistor low. That resets the latch circuit, turning everything off. Now, the circuit truly works with a single button. Press once to turn it on, press again to turn it off. But there is something I am not telling you, that if you're still holding down that switch, you will notice our circuit begins to toggle, which might not be nice somehow for some people. So to stop that from happening, all we just need to do is to take out the RC network to the collector output. With this way, it won't have control over the transistor switching at its base. So there we go, our circuit works better. But I wanted to take this even further. Instead of pressing the button, what if the circuit could turn on with motion? So at first, I added an LDR circuit with a relay, where the light changes trigger the switch. The idea was simple. When light hits the LDR, its resistance drops, reducing current from flowing into the base of the transistor to activate the relay, which is in parallel with the manual switch. When something moves in front of it, it blocks light from the LDR, increasing resistance and therefore triggering the relay. But this didn't work as much as I expected, which I knew there would be flaws to this circuit, and I would say a poor design, because an LDR doesn't actually detect motion, it only reacts to changes in light intensity. If the room is already bright, a small shadow won't do much. If the room is dark, it won't detect movement at all, so it wasn't reliable. I needed a better sensor. That's when I switched to a PRO sensor, known as passive infrared sensor. A PRO sensor doesn't detect light, it detects heat. Every human body emits infrared radiation. And when we move, the sensor picks up that charge. So I went on to make it better by building my work on a PCB design software and replaced the LDR with an AS312, a PRO sensor. But if you can't use it or have one lying around, because I didn't have them anymore lying around to use for this video, you can also as well replace yours with an IR obstacle sensor if you have them. The connection is so simple. What you just need to do is connecting its output to the base of the transistor while connecting the remaining pins to the power. And there you go, a simple smart motion detector circuit you built all by yourself. So what started as a simple transistor latch circuit turned into a motion-activated smart switch with no IC or microcontroller. Which motion sensor would you use? Or are you going to stick with the LDR? Let me know in the comment section. If you have ideas, let me know in the comment. And if you found this video helpful, don't forget to like, subscribe, and share. Thanks for watching.